Hello friends, I welcome you in lecture number 16 on higher order ODEs. In this lecture we are going to discuss modification rule for the method of undetermined coefficients. So we will understand this rule with the help of this example. Solve the differential equation y double dash minus 3y dash plus 2y equal to e raised to x using method of undetermined coefficients. So the first step is to find out the solution of corresponding homogeneous differential equation. So the corresponding homogeneous ordinary differential equation is, we consider right hand side equal to 0. That will be the homogeneous differential equation corresponding to given non-homogeneous equation. Now to solve this equation, first we have to solve its auxiliary equation. So the auxiliary equation is lambda square minus 3 lambda plus 2 equal to 0, and this is easy to factorize. We can rewrite minus 2 lambda minus lambda for minus 3 lambda, or minus 3 lambda we have replaced by minus 2 lambda minus lambda plus 2 equal to 0. So this we can rewrite as lambda common from first two terms minus 1 common from last two terms. So here lambda common, so we will have lambda minus 2. Here we consider minus 1 common, so we have lambda minus 2. And again we consider lambda minus 2 common, so we are having lambda minus 2 into lambda minus 1 equal to 0. Therefore lambda equal to 1, 2, and therefore the complementary function is c1 e raised to lambda equal to 1 into x plus c2 e raised to lambda equal to 2 into x. So this is the complementary function. Now what modification rule says, that your choice for particular integral depends on the function on the right hand side. Here function on the right hand side is e raised to x. So the family of derivatives for this function is set containing e raised to x only. Now whenever you want to find out particular solution using method of undetermined coefficient, first we will find out the family of derivatives corresponding to right hand side of given non-homogeneous equation. Then we must check whether any member of this family is present in the complementary function or not. So here we can see, here we have e raised to x, and e raised to x is present in the complementary function. The problems which we have discussed up to this lecture, in those problems we had considered those type of problems in which no member of this family were present in complementary function. But every time whenever you apply the method of undetermined coefficients, first you will have to write down the family of derivatives corresponding to right hand side of given non-homogeneous equation, and then before assuming particular solution or particular integral, you have to take care to check that any member of the family of derivatives is present in the complementary function or not. Now here e raised to x is present in the complementary function. So if we consider particular integral, if we consider choice for particular integral as a into e raised to x, then this is not proper choice. This is incorrect choice because e raised to x is present in the complementary function. So we have to modify this choice, and for modification we will multiply this family by x. So we have x into e raised to x, and we will consider this modified family for choice for particular integral. So we will consider linear combination of this x into e raised to x. So this will be the correct choice for particular solution of given non-homogeneous equation. So this is the modification rule. Whenever you assume your particular solution, before assuming particular solution, you must check whether any member of the family of derivatives of right hand side is present in the complementary function or not. If it is present in the complementary function, then you have to modify your family by multiplying with powers of x. Suppose my complementary function was c1x into e raised to x plus c2 into e raised to x. Then here right hand side is e raised to x. So family of derivatives contain e raised to x. Now e raised to x is present here, so we will modify by multiplying by x. So we have x into e raised to x. Now again we check x into e raised to x is present in complementary function, so this is also not correct family. So we again multiply this family by x and we obtain x square e raised to x. So now x square e raised to x is not present in the complementary function, so choice for particular integral in this case will be a into x square into e raised to x. So all we have to remember is no member of family of derivatives is present in the complementary function. If any member of the family of derivatives is present in the complementary function, then we multiply every member of the family by powers of x so that we have independent functions. Okay, so this is what we have to take care while assuming for particular integral in this method. So now we try to find out solution of this problem. So here right hand side is e raised to x. Okay, we can write here family of derivatives of e raised to x is set containing e raised to x, but e raised to x is present in complementary function. So we modify family of derivatives as, so modified family is x into e raised to x. So we modify family of derivatives by multiplying with x. So hence modified family of derivatives is x into e raised to x. This is just for understanding. You don't have to write down all these things in your examination. You can directly write down that your choice for particular solution. Suppose the particular solution is another name is particular integral, is yp equal to a times x into e raised to x. So now we know the method. We find out first and second order derivatives. So here we have x into e raised to x in the product, so we have to consider product rule. We consider x as it is, derivative of e raised to x is e raised to x plus a into e raised to x as it is, derivative of x is 1. Now again we have to apply product rule for yp double dash. Here we have to apply product rule. So same thing here, ax e raised to x, x as it is, derivative of e raised to x is e raised to x plus e raised to x as it is, derivative of x is 1, and derivative of a e raised to x is a e raised to x. So this is 2 times a e raised to x plus a x e raised to x. So we have all these derivatives which are required. So now we know that yp is solution of given equation, so it will satisfy given equation. Now yp is solution of given equation, therefore we can substitute yp in the given equation. Yp double dash minus 3yp dash plus 2yp, yp double dash minus 3yp dash plus 2 times yp is equal to e raised to x. Yp double dash is, now we substitute all these values, 2 times a into e raised to x plus ax e raised to x minus 3 times yp dash. Yp dash is ax e raised to x plus a e raised to x. Ax e raised to x plus a e raised to x plus 2 into yp, which is a into x into e raised to x, equal to e raised to x. Now we combine all these things. Here we have 2 times a into e raised to x, ax e raised to x. Here we take minus 3 inside the bracket, so minus 3 ax e raised to x minus 3a times e raised to x plus 2 times ax e raised to x equal to e raised to x. Now ax e raised to x plus 2ax e raised to x, that is 3 times ax e raised to x, that will cancel out with this, and this is 2a e raised to x minus 3a e raised to x, that is minus 1a e raised to x equal to e raised to x. So if we compare the coefficients, we have minus a equal to 1, therefore a is minus 1. So we obtain the value of undetermined coefficient. So therefore the particular solution or particular integral is, therefore the particular solution is yp equal to minus x into e raised to x. And finally we write down the general solution. Therefore the general solution is y equal to yc plus yp. Let me check what is complementary function. It is c1 e raised to x plus c2 e raised to 2x. c1 e raised to x plus c2 e raised to 2x, and yp is minus x e raised to x, where c1 and c2 are arbitrary constants. So this is all about modification rule. Again I repeat, whenever you are solving non-homogeneous equation by method of undetermined coefficient, you will find out complementary function. Suppose equation is of second order, then this will be the form of complementary function. Now suppose right hand side is Rx and family of derivatives is say y1, y3, y4 or y5, then we will check whether any member of this family is present in the complementary function or not. So if here y1 is present in the complementary function, so we will modify this family by multiplying every member by x into y5. Then again we will check whether any member of modified family is present in the complementary function or not. If it is not present, then our particular integral will be linear combination of these functions. For example, suppose complementary function is c1 e raised to x plus c2 cos 2x plus c3 sin 2x. suppose this is the complementary function, and suppose right hand side is say sin 2x, then family of derivatives of sin 2x is, as we know, sin 2x cos 2x. So this is the family of derivatives corresponding to right hand side. Now this sin 2x is present in the complementary function, so we will multiply this by x and we will consider modified family x sin 2x, x cos 2x. Now again we check whether any member of this modified family is present in the complementary function or not. So now no member is present in the complementary function, so our choice for particular integral will be linear combination of these two functions, ax sin 2x plus bx cos 2x. So we can discuss one more case. Suppose complementary function is say c1 plus c2x, and suppose right hand side function is say x, or suppose x square. Now family of derivatives corresponding to x square is 1x x square. Now if we check here, c1 we can write this as c1 into 1 plus c2 into x. So 1 and x are present in the complementary function also, so we multiply this family by x, so we have x square x cube. Again we check whether any member of this modified family is present in the complementary function or not. So we have this x present in the complementary function, so we again multiply this family by x and we find out new modified family. So this is x square x cube x raised to 4. Now no member of this family is present here, so this will be the modified family which we can use to write down the choice for particular integral. So now choice for particular integral is linear combination of these three functions, ax square plus bx cube plus cx raised to 4. Okay, so this is how modification rule works, and it is very important to check whether our family of derivatives, whether any function in the family of derivatives is present in the complementary function or not. If it is present, then we must modify the family of derivatives by multiplying powers of x, whatever powers are required to modify the choice for particular integral. So in next lecture we will discuss more problems of this type. I hope you like this. Thank you very much.